And I wanted you to rewrite this using positive exponents. And what you need to be able to do is figure out which factors are going to go in the numerator and which ones go in the denominator. Anything with a positive power stays in the numerator or stays where it is. It may start in the denominator. Anything with a negative power gets moved to the opposite or reciprocal location. And so if you look here, we have a base of 5, a base of y, a base of x, and a base of z. So the first thing you should do is distinguish the number of distinct bases, and then just work one by one and determine which one is going to be located where. So the 5, will it stay in the numerator or be moved to the denominator? Its power is positive, so it will stay. What about the base y? Has a negative power, so we have to move to the reciprocal location and then change the sign to a positive. Okay. You don't need to write a 1, so when we write our final answer, don't put a power of 1, just leave it blank. Okay. What about the base of x? Is it going to stay in the numerator or move to the denominator? Stay in the numerator. What about the base of z? It gets moved, and we change the sign to positive. So when we're looking at our overall solution here, the simplified form, 5x over yz squared will be your simplified form. Okay, try this one on your own. So once again, this is going to incorporate some of the rules from yesterday. Here we have a product with a power applying to that product. So we take the power of the product rule, and this power of negative 4 is going to apply to both the 2 and the c. So we have 2 to the negative 4, c to the negative 4, and d. So all I've done here is I've gotten rid of the parentheses or grouping symbols, which is the first step in order of operations. Okay. And now we can simplify. So this, we have a base of 2, a base of c, and a base of d. Is the base of 2 going to stay in the numerator or move to the denominator? It has a negative power, so it's going to move. We change the sign to positive 4. Is the c going to stay in the numerator or move to the denominator? Move. Change the sign of the power to positive 4. And is d going to stay in the numerator or move to the denominator? Stay in the numerator. And so here we wind up simplifying 2 to the 4th. Again, when you're looking at this, we have 4 2's. Easiest thing to do is think 2 times 2 is 4. 2 times 2 is 4. So we have a number of 16. And then c to the 4th we can leave as well. Hey, what do you think will happen if we enter this in our calculators? 2, if we were to actually keep it in terms of c to the power of negative 4, all times, we'll choose the letter d, and it shows us in that form. Okay. So once again, using your calculator may make it easier, but be prepared for either. Okay. You also might need to be able to recognize that this answer could also be written in the form with no fractions written, so using negative powers to represent fractions, is we could have 16 to the what power? What power would we need in order to represent 16 being in the denominator? 16 to the negative 1 represents this 16 being in the denominator. C to the negative 4, D. So this right here is an alternate form of the solution. Okay, obviously it's not the correct answer if it asks you to write it using a positive exponent, but it is an answer that represents this whole expression. Okay, it's not above me to put this form on a quiz. No, just to make you actually identify this form. Okay, like if I gave you a multiple choice question, okay, and why might I do that? Right, because your calculator is not going to give you this form. may test the understanding of what these mean. Okay? So be prepared for that possibility. What? All right. Are there any questions on what I just talked about? Like any questions? Meaning, if I were to open up a quiz. No, I'm just.
The same type of problem, different numbers than when you just. That one's so. Yeah. Let's be honest.
This power, you have a product with a power applying to every factor of that product. So this power of negative 2 is going to apply to the 3, to the x, and to the y squared. And then x to the minus 3 will fall out here. Okay, so now if we look to use the rules that we talked about yesterday, here we have a power to a power, so what are we going to do with the powers here? We're going to multiply, so we get y to the negative 4th. And now we have two common bases here. When you have two common bases and you're multiplying your exponents, what do you do with the powers? Add them. So we have negative 2 plus a negative 3 gives us a total of negative 5. Okay. So here is one form of the answer. If we were to write this answer using only positive powers, what are we going to do with this base of 3? Move to the denominator and change its sign. What are we going to do with this base of x? Move to the denominator and change the sign. What are we going to do with this base of y? Move it to the denominator, change the sign. Okay. Can't leave a fraction empty in the numerator, so we'll write a 1 there. And now we can simplify one little bit more. 3 squared is 9. X to the 5th, y to the 4th.
That's wrong.
Okay, let's take a look at the calculation. Okay, if you take 3x y squared.
But you need to put the x times y.
Yes. Yep, I'm going to talk about that in just a sec. Okay. Thank you for pointing that out. Okay, to the power of negative 2, all times x to the power of negative 3. Okay, so if you're going to enter your information in this form, okay, you got something that's written slightly different, right? Okay, because here's what your calculator reads. Any string of letters is read as a single variable. So the way that I entered this here, the xy, is read as a separate variable xy. It doesn't separate those as two distinct factors. So in order to do that, as Caroline pointed out, we need to multiply those variables. Anytime you have variables next to each other that are being multiplied, and you have to use what's called explicit multiplication. Okay, implicit multiplication means you just left it xy, and the calculator does not read implicit multiplication between two letters. Now, it does read implicit multiplication between a number and a letter only if the number is written first. So we've talked about that a little bit before. But if we add this multiplication symbol, and that's the only change we need to make, it will confirm that we got the right answer. Okay. So remember, as far as your calculator is concerned, 3x does equal 3 times x. That is how your calculator relates it. But if you put x3, it does not read it as x times 3. It reads it as x3 is the name of your variable. It would almost be like a subscript, x subscript 3. And so you got to be careful. Don't assume that your calculator knows when two variables are being multiplied by each other.